Domain of the first one. Domain. What's domain of the first one?
Alright. All real numbers but x cannot equal -3.
Okay, I like that. What does that mean then for our vertical asymptotes? X equals -3, correct? Okay. How do we find horizontal asymptotes? No, that's x-intercept, okay? So we look at the degree of the top, right? What's the degree of the top in this one? Degree of the top. 0, because there's no x up there, so it's 0. Degree of the bottom. 1. So we are in a bottom is bigger than top case, so that will be y equals 0. Second one, domain.
All real numbers but x cannot equal -3 again.
Same as the first, but a little bit louder and a little bit worse.
Second is best.
Do you get it? Second verse, same as the first, but a little bit louder and a little bit worse. It's the same denominator, so it should be the same domains. Okay. Which means same vertical asymptotes, right? X equals -3. Okay. Horizontal asymptote in number 2. Alicia? No. Y equals -2. I like that, because what's the degree of the top? 1. Degree of the bottom? 1. Those are the same, right? So when those are the same, then we look at the coefficients. And so then it becomes y equals -2 over +1, or simply just y equals -2. Third one, domain. Might have to do a little factoring first, right? Two numbers that multiply together to be +6 and add to be -5. -3 and -2, right? Okay, so what does that mean for our domain? No. +3, +2. Yep. So x can't equal +2 or +3. What does that mean for our vertical asymptotes? That I like better. Okay. Yep. X equals 2 and x equals 3. Horizontal asymptote. Y equals 3, because we have degree of 2 on the top, degree of 2 on the bottom. So we take the coefficients. 3 over 1 is y equals 3. Okay. A factor in number 4 again, too, so I can factor out an x. Leaves me with 5x plus 3. Okay, so that means my domain here is all real numbers. X cannot equal 0 or -3/5. Which tells me then that my vertical asymptotes are x equals 0 and x equals -3/5. Horizontal asymptote in this one, right? Y equals 0. Degree of the top is 1. Degree of the bottom is 2. So we're back into a bottom bigger case. Okay? Question. questions on that? In order to save us some time, what we're going to do now is we're going to work the 6 steps. Now, if you notice at the bottom of your page there's the steps, if you will, to solving or to graphing functions. Okay? You have those steps on your cheat sheet. Okay? And again, if you weren't here on Monday, to get your cheat sheet, go to Monday's notes, print out page number 1. Okay? And then you'll have your cheat sheet for you ready to go. Okay? So let's work our holes in our functions, which is step 5 on our cheat sheet. Okay? So let's work our cheat sheet. Step 0. And step 0 is important because we do it before we even start. What was step 0? Simplify the rational function. So can I factor anything out of the numerator of this particular rational function? No, it's going to stay x minus 2. Okay? Does the bottom of this rational function factor? Both perfect squares, and more importantly, there's a subtraction sign in between them. So what is the bottom factor to be? X minus 2 and x plus 2 is what the bottom factor is to be. Now, seeing that it's in factored form, do you notice anything about your rational function? They both have a common factor, right? And that common factor is x minus 2. So we can simplify our rational function all the way down to our new rational function of 1 over x plus 2. Now you might want to put a little box around that, put a nice little star by it, if you will, because this is your new function. Okay. And that function is what you are going to use the rest of the way through the problem. And you're going to use the new function, your simplified version, all the way through the rest of the problem. Okay? So, now, based off of your new function, what is the domain of that function?
All real numbers, but x cannot equal -2.
Which means the vertical asymptote of my new function is x equals -2. Now, I noticed from helping some kids in the MRC that when you are going to graph your rational function, okay, your asymptotes, remember, need to be dashed. Okay? Now, some people, I was noticing in the last class too, some people were using multiple colors, pen and pencil, or highlighter and pencil, or highlighter, pen, and pencil. They were getting all crazy good. Okay? Make those asymptotes stand out. Okay? All right? So that you can see it. First off, it's not a solid line. Second off, remember, that's an important line because our function can't cross over that. Okay? That's a wall, that's a barrier, that's an impenetrable object. Okay? Alright? So then we can now find the horizontal asymptote of our new function. What's the horizontal asymptote of our new function? Y equals 0, because the degree on top is 0, the degree on the bottom is 1. So we're in a bottom bigger than top case. So that's y equals 0. And again, that one goes on as a dashed line. Then we can find the y-intercept. How do we find the y-intercept of our new function? Plug 0 in for x. So we get 1 on top, and we get 0 plus 2 on the bottom. That is going to be, oops, it's jumping around already. See. 1 on top, 0 plus 2 on the bottom is going to be 1/2. That tells me then that my y-intercept is at the point 0, comma, 1/2. Then it says to find the x-intercept. How do I find the x-intercept? I set my numerator equal to 0. So in this case, my numerator is 1. I set that equal to 0. Can that ever happen? Can 1 ever be equal to 0? Okay, not at least in my world it can't. So I don't have an x-intercept. So I would just put none there. Okay, so it's not going to cross my x-axis. And that's important. Okay. Now we're going to skip ahead a little bit because now we're going to go to what I like to call step number 5. Okay. So step number 5 now says, okay, that was our whole step. Oops, let me actually put step 5. Perfect. Okay. So the first thing that you are going to do in your whole step is you are going to set your common factor equal to 0. Now you're only going to do step 5 if you factored something out in step 0. So maybe on your note sheet, put a little star next to step 0 that says, if we factor something out, you've got to do step 5. Okay? So in this particular case, we had x, what did we have? X plus minus 2 is what we factored out? Yep, x minus 2 we factored out. We set that equal to 0. So then we solve that and we get x equals 2. Okay? So we set our common factor equal to 0 and solve. Then we are going to plug that into the new function. So my new function was f of x equals 1 over x plus 2. So if I plug 2 into that, that would become 1 over 2 plus 2, and that's going to be 1/4. Okay. So the whole of my function, dear Liza, is at the point 2, comma 1/4. Okay. If you'll notice at the bottom of that page, it says that this is known in the mathematical world as a removable discontinuity. Okay? And the reason that it's called that is because we removed it from the problem by simplifying, but we still have to account for it on our function. Okay? So literally, on your function, or on your graph, at the point 2, 1/4, you are going to put a hole. So you're going to put an open dot, and that open dot cannot be filled in. Your function will go up to it, but that dot cannot be filled in. So you're not going to draw through that dot. Okay? With me? So we have enough points on this side of our function to figure out that our function comes in up here, and then it comes down, and then when I get there, I lift up my pencil and fusses that there, and then I go to the other side and go on out. Okay? Kruger said it best. I hadn't heard this description of an asymptote in a long time. Okay? Asymptotes are like magnets. Okay? When you stick a magnet to your refrigerator, does it go through the refrigerator? No, but it sticks right to it, right? So an asymptote, vertical or horizontal, is going to suck that function right down next to it, but it's not going to make it go through it. Okay? So we get that part of the function. Okay? Now, we just have to figure out where the function goes on the other side of that. And so what we're going to do then is let's pick some points on the left side of -2. So let's go with -3 and -8. Okay? Close to my asymptote, other side of my graph is why I picked those two. Okay? So that's going to be, my function is still highlighted down here. So if I put -3 into there, -3 plus 2 is -1. So I get 1 over -1, which is just -1. If I put -8 in there, I get 1 over -6, which is -1/6. Okay? So now I go back and come on now. Go plot those points. So that first point was at -1 and then -1/6. So there is my function on that side. Okay. Handle? We have just enough time to do this. Okay. Which is I think it's the one on the bottom of this, top of the next page. Top of the next page. Okay? Alright? So, step 0 says I need to factor, right? Simplify and factor, right? Okay? So can I factor anything out of the top? Factor out of 3, what's left over? X plus 4. Can I factor the bottom? Two numbers that multiply together to be -8 and add to be +2. Okay, so x plus 4 and x minus 2. X plus 4's cancel each other out, right? Okay, so that tells me that I have a hole, correct? Because something canceled out. So the first step that I'm going to do down here when I get to the hole is I'm going to say x plus 4 equals 0. So x is going to be -4, right? Because that's what I factored out. Okay? My new function then is 3 over x minus 2. Okay? Domain of my new function? Which means that my vertical asymptote then is x equals +2. Horizontal asymptote, y equals 0. Degree on top is 0. Degree on the bottom is 1. We're in a bottom bigger case. Y-intercept, if I plug 0 into my function, I get 3 over 0 minus 2, which is 3 over -2. So my y-intercept is going to be the point 0, comma, -1.5. X-intercept, I set the numerator equal to 0. Can I have an x-intercept? Clear? X-intercept? Can 3 ever be 0? Nope, so there's none there. Okay. So now we just got to go back and find our hole. We know that there's going to be a hole at x equals -4. We just figure out where the function is at -4. So I plug in -4 into my new function. I get -4 minus 2, which is -6. 3 divided by -6 is -1/2. So the hole is at -4, comma, -1/2. Except it's jumping around. Jump around. So I go 1, 2, 3, 4, and I put an actual hole on my graph. Do I need any more on that left sector of my graph? Oh, I think we got 2. 2 is good. Come through, stop, pick up, continue on. Okay. Do I need some on the right side of my graph? Yeah, probably at least 1, right? Maybe 2. So that, let's go 3 and 8. What was my function? -2? Yep, x minus 2. So 3 minus 2 is 1. 8 minus 2 is 6. Okay. So we get, oh, hold on, that should be 3 up top there. And then 3 up top here as 1/2. That makes a bigger difference. 3 is up there, 1/2 is down there, and shabam. Okay, and there's your graph. Now, one thing that I forgot to show you is on a graphing calculator what a hole looks like. So I'm going to go back to the very first example that we did, okay? Because here's the first example that we did. And so if I go through here and I trace my function, okay, so we found on that first function at -8, we were at -1/6. Yep. And then we went to -4, and we were at -1/2. Yep. And then at -2, it was undefined. That was our vertical asymptote of that first function. Okay? And so then we come through, and at -1, if we would plug that in, we got 1. Yep. Okay? And at 0, there's our y-intercept. Okay? Now hold on. Here's what it looks like. Just tap the brakes. You're not going anywhere, right? Because, Haley, what do you got to remind me? Nobody's leaving. Okay? So this is what the hole looks like on a graphing calculator. It looks like a vertical asymptote, but if you go past it, it looks like it's a continuous function. Okay? But there is really a discontinuity there, and so it looks like a vertical asymptote. No. It's still going. Yeah. Okay? Alright? Now, the reason that I had to keep you here is on Friday, we forgot to hand out, or actually not on Friday, on Monday, we forgot to give you the formative assessment that was supposed to be due today. So today, we're giving you the formative assessment, and it's due on Monday. Okay? My recommendation for you on this formative assessment is that you work those 7 steps, every single one, even if it's not asking for what the 7 steps are. You do those 7 steps every single time. Okay? Have yourselves a good day.